Let's take a look at lesson 7.3. This involves some antiderivatives involving the trig functions. You'll note we've done some antiderivatives of the trig functions. If you look at page 201, it shows the derivative rules, and we've done those rules in reverse as antiderivatives. We're going to have some undoing chain rule. If we look at this first one, what we have is a power, sine to the fifth power. I'm not going to rewrite all of them, but I want you to remember the notation for that. So that means we're going to work power rule in conjunction with undoing chain rule. Notice the derivative of sine, the quantity is cosine, which is there. I started on my power rule. It's going to be sine of x to the 6, because I add 1 to the power, divide by the new power of 6 plus c. And then I can move the 6 back in if I wanted to. Let's take a look at this one. It's similar. I'm going to notice I have cosine to the 4th. And the derivative of cosine, well, it's negative sine, but we can deal with that. I'll work power rule. I'll leave the exponent in there. Add 1 to the power. Divide by the power. But since the derivative is supposed to be negative sine and we just have the sine, we'll need to divide by a negative 1. In looking at this one, we want to do it in a similar fashion, but you'll notice both of these have powers. The key is recognizing what comes out of chain rule, as in the derivative of sine was cosine, the derivative of cosine was negative sine, and then here, well, which one's resulting as part of chain rule? Well, that's the secant square because that's the derivative of tan. So we're going to operate on this. We'll have tan to the 11th of x divided by 11, and then since the derivative of tan is secant squared, we'll finish with the plus c. You'll see quite a few problems in that form on the assignment. However, some problems aren't accessible in that way. If we look at these two, we don't know a function that has a derivative of tan squared of x. Yeah, we can do the antiderivative of 1, but not this piece. And over here, sometimes we can do antiderivative quotients if we bring them up, or do a natural log. But the natural log only works if the derivative of this is here in some form and it's not. Well, the answer to these are to use identities. All right, you don't have to groan about it. So let's reference your Google Doc if you need to for some of the trig identities. This is in the Pythagorean section. This can be substituted with secant squared of x. And then what has a derivative of secant squared? Well, that's tan of x. And we're through. This one, we're going to make use of the ratio identity that says we can get cotan in terms of sine and cosine. Cotan's derivative goes cosine over sine. I'll multiply by the reciprocal, see if we can get something to cancel. I'll recopy my cosine. The reciprocal of this is going to be sine of x over cosine of x. Hey, how about that? The cosines cancel. And our finishing task is, well, what has a derivative of sine? What has a derivative of sine? Well, cosine has a derivative of negative sine. So this would have to be negative cosine of x plus c.